Okay, I think we seem to be ready now. Are you all hearing me?
Yes, sir.
Yes. Okay. All right. Good evening. Let me see. I don't see Yuri Butler. Are you there? I guess you got off. Okay. So Miss Thompson, right now, it seems as if it's just you at this moment. I don't see the other person. He said he was on his way home, so I guess when he gets home, he will join the class. But did you manage to complete the homework, Ms. Thompson?
Sorry, I did. I did the homework.
Okay, so you could take a picture of it and send it to me. Now the answers it would be on the presentation that I sent to you. I don't know if you saw it.
I saw an email. I just didn't have a chance to look in it. I was trying to hurry to log on.
No, I'm talking the one that I sent you from the last class.
Prior. Oh.
Yes.
Oh, yeah.
Mm-hmm.
Oh. And
So,
okay, so I didn't realize that was the answer for these.
Yeah. So I wanted you to, I do that purposely so that you could check to make sure what you're doing is correct. And if you can't get the answer that's there, then when you come to class, you could let us know which questions you were having some difficulties with, so we could discuss it. Okay.
The only ones I really had a problem was with when the rate was a percentage.
Mm-hmm.
That's the only thing that I was a bit uncomfortable. I couldn't figure out how to get it to a whole number to calculate the answer.
Uh-huh. So is there a particular question you were thinking of? You can let me know so I could.
If there was hold on, let me see if I can find one.
Give me a question, yeah, one of the questions.
Take number 9. Yes. A40, number 9.
All right, that's the one that said Dan Smith real estate taxes of 640, 149 were due. Okay. So you were saying now, what was the issue with that?
For me, I couldn't figure out how to get the 13 and 3/8% to a whole number to calculate.
Okay. So that's 13 and 3/8%. So 3/8 would be equal to what as a decimal? When you divide 3 by 8, what do you get? You have a calculator there?
I do. 0.375.
So in decimal form, that would be 13.375%. And then you would change that to a decimal by moving the 0.2 places to the left. So that would be 0.13375 as a straight decimal. Yeah.
Okay, so you're saying.
So you're going to change the decimal portion. Sorry, you're going to change the fractional portion to a decimal. And then it will still be 13.375%. And then you want to change that from percent to just a regular decimal. So you're going to divide by 100. So you'd move the 0.2 places to the left. That becomes 0.13375. And then you could use that in your formula to do your calculation.
So would we use the whole 0.13375 or just like the whole 0.133 or 134?
Well, if the question asks you to round it off, you do, but they didn't ask you to round it off here. Because if you
No.
round it off, it's going to affect the accuracy of your answer.
Right. That's what I'm trying to figure out how, if if it asks you to round it, then you would round it. If not, you would just use it as is.
And usually when the question asks you to round it, they actually want you to round the answer. So you would use the percentage in its full form, and then when you get your answer, that's when you would round at the end.
Okay. Yeah. All right. Thank you. Okay, so I'm gonna attempt those probably later on after class.
Okay.
I think it was like 2 or 3 of those with the fractions as a percentage. I didn't get to do.
Okay. So, and like I said, the answers are there. So if you aren't able to get the answer, you could always, make some contact or send an email or a message, and then I could.
That's fine. Thank you.
Okay. All right. So once you get a chance to, you could send me a picture of it so I could credit you for having done it.
Okay, I will.
The homework is for practice. Okay. All right. So now for today, we want to look at the chapter 2 and chapter 3, which chapter 2 deals with fractions, chapter 3 deals with decimals. Are you seeing the screen?
Just your name. There's nothing sharing.
No? Oh, okay. Let me double check here then. Yeah.
Okay, there we go.
Okay. All right. All right. So, the question is asking how are fractions different from whole numbers? What do fractions do? What's the purpose of a fraction? Why do we need fractions?
To give us a percent, not a percentage, but a portion.
Okay, all right. That's the essential purpose of it, to give us a portion of a whole. And how are they represented in comparison to regular whole numbers?
A fraction possesses a numerator and a denominator.
Okay, so we use the term numerator and denominator. And what is a numerator? What is a denominator?
The numerator would be the top number, and the denominator would be the bottom figure.
Okay, so now.
So the numerator will represent the portion, and the denominator would represent the whole.
Okay, so we have numerator on top and denominator at the bottom. And you say the denominator basically tells you how much the whole is divided into, and the numerator tells you how many parts of that whole you are looking at. All right. So if I give you a fraction such as 7/8, what does that mean? 7/8.
7 pieces of that 8.
7 pieces
of the 8.
Of 1/8. Okay, so it means then you have divided something into 8 parts, and you are taking 7 of those 8s. So what's going to be left?
1/8.
1/8. Okay. So a fraction basically is telling you first how many parts you divided the whole into, and then the numerator, how much of those parts you are working with, how much part of those parts you're taking out. And so that's how we represent the fraction. And this type of fraction is referred to oftentimes as a common fraction. A common fraction will have a numerator, a denominator, and a fraction bar separating the numerator from the denominator. All right, so we have several types of fractions, and you should be familiar with these types. We have the proper, the improper, and the mixed numbers. Looking at those examples below, you should be able to tell me, look at A, B, C, D. Tell me what type of fraction each of those represents.
A is a proper fraction. B is an improper fraction. C is a mixed. And D is a proper.
She's a whole number.
The whole.
Well,
okay. I'm looking at what he had the options he have.
Yeah.
He's a whole number because the numerator and denominator is the same as equal to 1.
Okay. Now, if you look at those definitions, the first definition, the proper has a value of less than 1. Its numerator is smaller than its denominator. Improper fraction has a value equal to or greater than 1. Its numerator is equal to or greater than its denominator. And of course, a mixed number would be a number whose sum, who is a sum of a whole number greater than 0 and a proper fraction.
So if that's equal, that's considered improper. That's an improper fraction then.
Well, according to the definition that the book gives, it would be improper. Okay. So all
it would be improper?
Yes.
Yeah.
According to the definition that's given in the in your textbook on page 336. Okay.
Equal.
Yeah, because it's equal to 1. Anything equal to 1 or greater, in this case would be improper. So all proper fractions, the top number has to be smaller for it to be considered a proper fraction. Okay. So once the top number is equal to the bottom or greater than the bottom, then it is improper. Okay. So moving on, one of the things we often have to do with fractions is a conversion from one form to the next. So we have the first fraction that you see there is an improper fraction. And that improper fraction is 1/60/9. And we can convert that into a mixed number because if you divide 9 into 16, you're going to get a whole number, and then you're still going to get something left over, which you can write as a fraction. So what would be the procedure for that? Converting 1/60/9 into a mixed number.
I guess we could split the numerator and divide 9 into 16. I hope I'm saying it right.
9 into 6, okay.
So 9 could go into 16 once, given a remainder of,
So when you subtract, you get what now?
7.
The remainder is 7.
7.
Okay, bring the 0 down. 9 into 70.
It is 7, I think. 7 and 9 is 63. 8 and 9 is 72. Yeah.
So that's 7. So nothing else to bring down. So then that's equal to 17. And your remainder is 7/9. So as a mixed number, then 1/60/9 is equal to 17 7/9. Okay. So we went from improper to mixed. Now we have a mix that we want to change to an improper fraction. So what's the procedure there?
We will have to multiply the denominator to the whole number.
Okay, so 9 times 8 equals
72.
72.
Right.
And then you'd have to add that with the numerator.
That's 5, okay, over 8, so that's equal to
72, 77.
Over 8. All right.
Wow.
Okay, so the steps are right there. Multiply the denominator of the fraction by the whole number. Add the product from step 1 to the numerator of the whole fraction. So that's 72 plus 5. Put the total from step 2 over the denominator. So that would be the 77 over the 8. And so you got your improper fraction. All right, so another form of conversion is to convert your fraction into a lower term. Sometimes you get fractions and they are not in lowest terms. And it is useful to be able to convert the lowest terms when you are working with fractions. So how would you go about writing this fraction 24 over 40 in lowest terms?
We have to find out what is the, I see you have the greatest common divisor.
Okay.
So I think the greatest one is 4. No, I think it's 8.
8, okay. Yeah. 8 would be the greatest number that could divide both of them. So if you divide 24 by 8, you get?
It's 3.
And 40 by 8 is?
5.
5. So your simplest form is 3 over 5. Now, of course, you don't necessarily have to use the greatest common divisor. You could use smaller divisors, but you just have to do more working. Give me a smaller divisor that you could have used instead of 8. Just looking at those numbers.
Like you say, 4.
Yeah, 4.
You could have used 4, or you could even use 2.
2, yeah.
Yeah, so 2 into that is 12, 2 into that is 20. Then you could use 2 again, 2 into that is 6, 2 into that is 10, and 2 again, 2 into that is 3, 2 into that is 5. So you end up with the same result. You just end up doing more working. So if you can find the highest common denominator, that reduces the amount of calculation you have to do. But if you can't, you could find lower ones and just keep dividing by common divisors until you can't reduce it any further. So 24 over 40 is equal to 3/5 in lowest terms. Okay. All right. So here we have the divisibility table at the top in green. And that divisibility table is helpful when you want to reduce fractions to lowest terms, because if you could identify certain principles or use certain principles, it could speed up your effort to reduce. So numbers that are divisible by 2, for example, right at the first portion here, it's saying that the last digit is going to end in 0, 2, 4, 6, or 8. What type of numbers are those that end in 0, 2, 4, 6, or 8?
Even.
Even numbers, right? So even numbers would end in 0, 2, 4, 6, 8. And so once a number is even, so if you have 2 even numbers to reduce, you know right away you can divide by 2. Now, if you want to know whether you could divide by 3, it says the sum of the digits is divisible by 3. So if you look at the one they give you as an example here, 36 over 69, when you add 6 plus 3, the digits in that number is 6, and the first number is 6, and 6 and 3 is 9. You know that 9 is divisible by 3. So right away, it means 36 is also divisible by 3. And for 69, 6 and 9 is 15. 15 is divisible by 3. So it means right away that 69 is also divisible by 3. Okay? So anytime you add up all the digits of a number, if the sum of the digits is divisible by 3, it means the number itself is divisible by 3. So that's a quick way you could look at a number to decide if it's divisible by 3. In the next one, 4, it says the last 2 digits can be divided by 4. So in the example they give you there, 140 over 160, the last 2 digits of top is 40. Right away, you should know that, well, 40 is divisible by 4, so it means that 140 is also divisible by 4. 60, in the next number, it's 160. The last 2 digits would be 60. 60 is divisible by 4, so it means 160 is divisible by 4. So any number where the last 2 digits is divisible by 4, the entire number is divisible by 4. Now everybody should know the rule for 5, and it's just once a number ends with 5 or 0, it's divisible by 5. For 6, they say here the number is even, and 3 will divide the sum of the digits. So basically for 6, they're combining these two for 6. So it's even, and the sum of the digits is divisible by 3. If that happens for both numbers, then the number is, if those 2 rules apply to the number, then the number is divisible by 6. And then lastly, well, everybody knows the rule for 10. Once it ends in a 0, it's divisible by 10. So those are some of the common divisibility rules that it's useful to know of. So when you're trying to reduce fractions or cancel, you could readily see which numbers you could use to do your canceling or reduction. Now, the opposite of to reduce, of course, is to raise. So if you look at the bottom section of the screen, you will see 2 steps for raising. So essentially what we are doing here, we are writing the fraction in another form. So you have 16 over 30 is equal to something over 300. So basically we have increased our denominator from 30 to 300. So whatever factor we're using to do that, we have to do the same for the 16 to find what the new numerator should be. So anybody could tell me what the new numerator should be in this case?
10, that'll be 160.
160, and how did you get your 160?
I did multiply the denominator by 10, so I did the same with the numerator.
Okay, right. So to keep the value equal, whatever you multiply the denominator by to get the numerator, in this case you said 10, then you have to do the same thing with the numerator. So you multiply them by 10, so that would be 160. Okay. And so what would be the factor for 9 over 20 to equal blank over 60? What's your multiplying factor there? Ms. Thompson?
I have no idea.
You have no idea? From 20 to 60? What can you multiply 20 by to get 60?
What? Repeat it again. Sorry. What can
you multiply 20 by to get 60? Are you seeing my screen?
I am.
Yeah. So our denominator is 20, and we are changing it so that the fraction is now out of 60. So what are we multiplying 20 by to get 60? All you have to do is divide, and you'll see How many times can 20 go into 60?
3 times.
Right. So if you have to multiply 20 by 3 to get the 60, the same principle must be used to find what the new numerator is. So you multiply it by 3. So you're going to multiply this 9 by 3. So you are going to get 3 nines are
27.
27. So your numerator is going to be 27. Okay. So the principle here, it's you divide the new numerator by the old denominator to find what the common number is that raises the fraction. So in the first one, 30 into 300 goes 10 times. So once you get that common number, you're going to use that number to multiply the numerator to find what the new numerator should be. So 10 times 16 is 160.
Is it always going to be this easy?
You want it to be more difficult? Okay.
I mean, you could show me this easy one and I could get this.
Yeah, but it's the principle is the same. It's just that the numbers may be a little more complicated, but the principle is the same. You're looking to see what is the number you need to multiply the smaller one by to get the bigger one, and use that same number to multiply the numerator. Okay? So it's a principle I needed to be aware of. All right? Sometimes you could actually go the opposite direction. So if I give you, for example, let's say I give you 12 over 20, and I say to you that's equal to, let's say, blank over 10. What are we doing in this case?
Okay, so you use 10. You would say 10 divided by 20. 20 divided by 10, my bad. So then you would times the 10 by the 12. Yes?
You see, with the first set that we're doing, we were raising. We went from 30 to 300, then from 20 to 60. But this time we're not raising, we're actually going down. So we're going from 20 to 10. So it means then that the numerator is also going to be a decrease. But you're looking to see now from 20 to 10 means you are finding what? What fraction of the 20?
The number,
we're going from 20 to 10. What are we doing here? A half. So you're going to have to do the same thing with the numerator. So what should the numerator be?
6.
6. Okay. So you look for the pattern between the two denominators, and you use that same pattern for the numerators.
Okay, give me another one like that.
Okay. So let's say we give you 5 over 12 equals to over 72.
So we using, that's what, 6? Or
6?
12? 76.
What times 12 gives you 72?
12?
12,
sorry,
12,
what are you asking? What are you asking me?
We move from 12 to 72. So what are we multiplying by here?
6 12s.
Yeah, that's 6. So you're going to do the same thing here. So your numerator will be?
30.
All right. So again, you're looking for the pattern. What is the relationship between the 12 and the 72? You have to multiply by 6 to get it. So you follow that same pattern to move from the 5 to find what the new numerator should be. So in some cases, we are increasing. In some cases, we are decreasing. So when we increase, we are multiplying. When we decrease, we end up actually dividing. So right here, you divide it by 2. So you have to divide this one by 2.
Okay.
2 into 20 is 10, 2 into 12 is 6. Okay?
Okay. Yes,
so
sir.
that's the, okay. All right. So this brings us now to the addition of fractions. And it mentions here like and unlike fractions. What's the difference between the like and unlike fractions? What makes fractions like? What makes them unlike?
Guess the denominator.
The denominator. Okay, so what about the denominator for like fractions?
You could, for the first example, you could use 7 as the denominator add.
Mm-hmm.
For the second one, because the two denominators are different, you have to use a number that could go into both. Or
okay.
Yeah.
Okay, so what's the answer for the first one?
7. Sorry.
I'll be 5 over 7.
5 over 7.
That's
okay.
it? Wow.
That's it. Because what that is saying, this one is saying, I divide something into 7 parts and I take 1. This one is saying, I divide something into 7 and I take 4. How many 7s do I have in total?
Okay.
That's equal to 5 over 7. Okay? Once the denominator is the same, all we are doing is adding the numerators to tell you how many parts you have altogether. Now, in this second one, the denominators are not the same. In order for you to add or subtract fractions, you must have the same denominator. So if the denominators are not the same, you have to raise the fractions like what we were doing here. We have to raise them using a new denominator. Okay? Now, sometimes you could use one of the denominators that's in the fractions you have to add, but sometimes you have to find another number to use as the denominator. Can you use any of those numbers there as a denominator for the addition?
21.
You could use 21 because both of them can be, can divide 21. So if you change, so you're going to change this now to something over 21 plus something over 21. Now, this was 7. You change it to 21. So what will you change the denominator, the numerator to?
24.
Okay, how did you get that? You jump from 7 to 21. The same principle you were using right here, that's the same principle you're going to use. Your denominator was 7, but you raise it to 21. How can you raise 7? What's the pattern for raising from 7 to 21? What are we doing?
I can't remember if it's multiply or divide. 7 into.
Well, divide going to make it smaller, multiply going to make it bigger.
Make it big. I know. So that's
so
what
you're making it bigger because you're moving from 7 to 21.
Okay, so 7.
Okay, so how can you get from 7 to 21? What are you going to multiply by to get from 7 to 21?
7 times 3.
Right. So if you have to multiply by 3, you have to do the same thing with the numerator, times 3. So when you times that by 3, what do you get?
3 times 3 is 9.
9. Now look at the next fraction, 5 over 21.
That 21 into 21 is 1.
Mm-hmm.
And then 5, is it 5 times 3?
Oh, you got a 3. You said 21 into 21 is 1. So you're going to multiply the 1 times the 5. See, now, once you already have that denominator that you had before, you don't have to change that particular fraction. You see, you chose 21 as your denominator. But 5 over 21 was already had that as its denominator. So there's no need to change it. So you just bring it down as 5 over 21. It's the one that didn't have the 21, that's the 3 over 7. That's the one that you need to change. Okay. Now the two have the same denominator, so you can now add. So your answer should be
14 over 21.
Okay, 14 over 21. So when you look at this, is it in its lowest terms?
I guess we could use 7 again.
Yeah, 7 into 14 is 2. 7 to 21 is 3. So in lowest terms, it would be 2 over 3. Okay. The same principle applies for subtraction. You must have the same denominator in order for you to subtract. So if you look at the example that's there, 9/10 minus 1/10. What's your answer?
8/10.
Okay, that's equal to 8/10, which of course could be reduced to what I did. 8 over 10. And that could be reduced to 4/5. So 2 into that is 4, and 2 into that is 5. So that's equal to 4 over 5. Okay. Now look at the next one. Can you subtract?
No, sir.
What you need to do, you need to find a common denominator for those. Now you can't use the 7 because the 4 won't divide the 7, so you need to find a common denominator. So what could we use as a common denominator for this one?
28.
28. Okay. So we're moving from 7 to 28. Miss Thompson.
Hi.
What is the factor there? If you from 7 to 28, we're changing the denominator from 7 and we're making it 28.
So 7 into 28 3 times.
No, not 3.
7 times 3 is 28.
7 times 3 is 21.
Okay.
Yeah, go one step more. 7 times what give you 28?
Repeat that again for me, please. Sorry. 7 what?
You said 7 into 28 was 3, but I was telling you that 7 times 3 is 21. So it's not 3. What are you going to multiply 7 by to get 28?
7 times 4 is 28.
4, right. So you multiply them by 4.
7 times 4.
So you have to do the same thing with the 6.
6
so
4
6
is a 24.
So that should be 24. Okay. And then the second fraction, which is a quarter.
Seven. Hold on. So we say 4 times 7 is 28.
Right. So.
And then 4 times 1.
No. What did you multiply the 4 by?
7.
Right.
4
so you
times,
have to multiply.
Okay, it's 1 times 7. 1
right.
times 7.
Equals
7.
7. Okay. So now you have 24 over 28 minus 7 over 28. And so that now gives us what's our answer?
18 over 28.
18, you're off by 1.
19. Hold on,
You're
let me
off
see.
by 2.
17 or 28?
17. 17 over 28. Okay. So when you subtract 7 from 24, you get 17. 17 over 28. Can that be reduced further?
No.
No. That's the lowest term right there. Okay. Okay. I think I need to give you another one to work on. So I'm gonna ask you to do 5/8 plus 2/3. Do that one. 5/8 plus 2/3. I'll give you a couple minutes and I'm gonna call on you to tell me what you did. Okay, what's the common denominator when you use for that one?
$24.
24. Okay. Okay, so we're going to change both of them so that 24 is the denominator. Okay, so for the first fraction, 5/8. When you change that so that the denominator is 24, what would be the numerator?
It will be 15.
15? Okay.
Yeah.
Because we are multiplying 3 times 8 to get 24, so we have to say 3 times 5 is 15. Okay, and then what would be the numerator for 2/3 when you change it to a fraction out of 24?
The denominator was multiplied by 8, so you have to be consistent with the numerator, which gives the sum of 16.
16. All right. So you multiply 3 times 8 to get a 24, so you have to multiply the 2 by 8 to get 16. So when you add that together now, you're going to end up with 31 over 24. Is there anything you could do with that 31 over 24?
We could convert it into a mixed number.
Okay, you can convert to a mixed number because it's an improper fraction. So you say 24 goes in 31 once, and your remainder is 7 over 24. Okay, that's 1 and 7 over 24. Okay. All right, so I'm going to move on then. Okay, so let's look at some of these questions here. They have, I'm going to look at this one here, B. How is that different from what we've been doing so far in terms of adding fractions?
Both whole number, I mean, they improper fraction. Well, Mixed numbers.
Mixed numbers. So how would we tackle that one? So we have 2 and 3 over 4 plus 6 and 1 over 20.
Do we change those to improper fractions?
Yeah, 2 times 4 plus 3.
Or do we find the LCD? Or do we find the LCD?
We have to find the lowest common denominator, but I am thinking you have a whole number here, you have another whole number here. You could deal with the whole numbers first.
Okay.
You would get 8, and then you would have the 3 over 4 plus the 1 over 20. I mean, you can do 2 3s, 2 4s, 8, that's 11 over 4, 6, that's 1, 21 over 20. You could do that, but it's just that, you know, you have more involved working.
Okay.
So if you could do the whole numbers first, that would kind of simplify your working. All right. So now what would be your common denominator in this case?
It's 20.
20.
20. Okay. So now you need to change 3 over 4 to something over 20.
Would be 15.
15. Okay, because you're multiplying by 5. 5 4s are 20, so 5 3s would be 15. And of course, the second one, it was already out of 20, so you just put 1 over 20. So your answer then would be 8 and 16 over 20. Okay. And that 16 over 20 could be reduced to 8 and 4 over 5. Okay. All right. Do this one. 5 and 3/8 plus 2 and let me see. I gotta change this. Sorry. Let me change that to okay. My pen. Oops. Trying to get my pen back. Okay, ink tools. Let's see. 3 and 2/5. What up? I think it's playing games. All right, I'll just read it out and you could go ahead and attempt it. 3 and 2/5 plus 1 and a third. 3 and 2/5 plus 1 and a third. 1 and 1 over 3. Let me see if I get this pen back to right. Okay, so what's your common denominator for that one?
15.
Okay, so when you add the whole numbers, you get 4. And you're going to use 15 plus 15, okay. And then when you change 2/5 to something out of 15, what's the numerator? What are we multiplying the 5 by at the denominator to get the 15 at the other denominator? Are we moving from 5 to 15? What are we multiplying by?
You have to, that's 5 and 3. So 2 and 3, that'll be 6.
6.
On the left-hand side.
Mm-hmm. And then the other one?
That'll be 5.
Okay, 5 times 3 is 15. 5 ones are 5. Okay. So when you add it up now, you're going to get 4 and
11 over 15.
11 over 15. Okay. All right. Now, when we have to subtract, we basically follow the same steps. So I want us to do this subtraction right here. 8 1/4 minus 3 9 over 28. So we follow the same procedure. 8 1/4 minus 3 9 over 28. So if we subtract the whole numbers first, what do we get?
5.
5.
Okay, so that's 5. And then we now need to find a common denominator for both of those.
28.
Okay, 28 is correct. All right. So we need to change the numerator from 1/4 to something over 28. 7 over 28. Okay, because 4 into 28 is 7. 7 ones are 7. And the 9 over 28, we don't have to change because it was already out of 28. So where do we go from here?
So, right.
Get up a negative fraction.
Negative.
So that'll be negative 5.
You don't have a negative fraction because you have that 5 that you have a 5 that you could use. You have that 5. Yeah, that 5. That
okay,
5.
So why will we change the left into an improper fraction? So 28 times 5 plus 7.
You could
28 times 5 plus 7.
Yeah, you could do that. That's a good way to do it. Yeah, you could do that. But you have a quicker way where you could just borrow.
Oh, well, I don't know. So you
borrow from the 5.
Okay, so we'd have to take we add so it'll be 4. It'll be 4.
Okay, that would be 4.
7 over 28.
But when you borrow that 1 from the 5, listen now, when you borrow that 1 from the 5, you're going to change it into a fraction. And you're going to use that same base as the fractions you are dealing with. So if you borrow 1 from the 4.
Put that on the 7, eh?
No, you can't put it on 7 because you have to change it to a fraction. And you have to use the same base that you're using with the other two. What's the base for those fractions?
28.
So what will be the numerator for the one that you borrow?
28.
28.
28 over 28. All right. So that one that you borrowed will become 28 over 28. Okay. So that's 4, and 28 over 28 plus the 7 over 28
29.
minus
So
the 9 over 28.
So you put in a bracket 8.
You don't really have to, but you can, because 4 and 28 over 28 is like 4 plus 1. 28 over 28 is 1. Okay. So that's 4 plus 1, which is 5. But you changing it into 20, so you could use it to help you finish your calculation. So if you have the 28 plus the 7 that was there before, that gives you 35, and then you're going to take away the 9. So when you do that, what you're going to get?
35 minus 9 is 20. I'm doing this out of my head. It's 26.
26. All right. So that's going to be equal to 4 and 26 over 28, which could be reduced to 4 and
13
over
14.
14, right. That's the lowest term. So not every subtraction requires you to do that borrowing. It only happens when you have to subtract the larger numerator from a smaller one, then you could borrow from the whole number. But whenever you borrow from the whole number, you have to change it using the same base as the other fractions you're dealing with. So whatever the base is for those other fractions, you're going to change it to the same base. Of course, whatever base it is, the numerator will be the same. So if you are dealing with 12ths, then it will become 12 over 12. If you're dealing with quarters, it will become 4 over 4. So whatever fraction you're dealing with, that's what you're going to use. You're going to convert that one that you borrow into. Now, what Mr. Butler said about changing that to a improper fraction, you could also do that. 5 times 28 plus 7. And then you could convert that to improper, and you could do your subtraction. You get the same answer. But it's just, well, to me, it's a little more work, but you will get the same answer. Okay? So that's another approach you could use. All right, so before we move on, I'm going to ask you to do this other one, which is kind of similar. Do that. 9 and 1/8 minus 3 and 7 over 32. I want you to do that. Okay, so the whole number portion gives you what?
6.
And your common denominator is?
32.
32. And what do you have for your numerators?
4 over 32.
Okay, 4 over 32. Okay,
7.
and then 7. So this is another one where we have to borrow from the whole number because you won't be able to take the 7 from the 4. So if you borrow, you're going to end up with 5, and then the one that you borrow will become what?
32 over 32.
Okay, very good. 32 over 32 plus the 4 over 32 minus the 7 over 32. All right, so that's going to end up being 36 minus 7.
29 over 32.
Okay, 29 over 32. Okay, very good. Okay, so the next operation we're going to be looking at is multiplication and division of fractions. So in your book on page 47, going to page 50, you will see these steps for multiplying. They have a step for proper fraction and they have a step for mixed numbers. Now, unlike addition, where you have to find common denominators and subtraction, that's not required when you're multiplying and dividing. Okay, so addition and subtraction have some similar steps. Multiplying and dividing also have some similar steps. So try not to get the two confused. So we want to look at some examples using the steps that they mention. So if you look at number 1, it says 4/8 times 4/6. They say use the cancellation technique. What's the cancellation technique?
So be considered like cross multiplication. Reducing. No, I lie. Let me use better terms. It's like like diagonally reducing the fractions.
Okay, you could reduce. Yeah, you could reduce. Okay, so for example, you could say 2 into that is 2 and 2 into this is 3. So you have done some canceling there. Then you could go again and say 4 into this is 1 and 4 into that is 2. Then you could say 2 into 2, 1 and 2 into 2, 1. So there's nothing else we could do. So answer then would be what's our answer now? After all that canceling.
1 over 3.
1 over 3. 1 times 1 and 1 times 3 gives you 1 over 3. Okay, so that's the canceling technique. Now, another way you could do it, you don't have to cancel. You could have just said 4 times 4 over 8 times 6. So this is another approach. 4 4s are 16. 6 8s are 48. So you have 16 over 48, and then you reduce that. So if you want to reduce that, you could say now 8, or you could use, let's use 4. 4 into that is 4. 4 into this is 12. 4 into 4, 1. 4 into 12, 3 equals 1 over 3. So you could either cancel, or you could just multiply the numerators, multiply the denominators. Okay? So if you look at the rule for here, it says for proper fractions, multiply the numerators and the denominators, reduce your answer to the lowest terms, or use the cancellation method. Okay? Now, what did they say about the mixed number? If you have to multiply mixed number. Say that again?
No, sorry, I was reading it.
What's the first step for the mixed number?
Convert it to improper fraction.
Okay. So when you are doing the multiplication of mixed number, you have to convert it to an improper fraction. Now, they didn't give us any in this example, but let's look at one. So if I say 5 and 3/8 multiply by 2 and 1/5. Okay, so we want to do that mixed number multiplication. So first step would be to say equal.
That would be 8 times 40 plus 3 is 43 over 8.
43 over 8 times
5 times 7 plus 1 is 11 over 5.
11 over 5. Now, can we do any canceling here?
No.
No, there's nothing we could cancel, so we just have to multiply the numerators, multiply the denominators. So 43 times 11.
I know a calculator with me right now.
Okay.
473.
Okay. 473. And then 5 8s are 40. Okay, so you simplify that. 14 to 47 goes 1 time. Remainder 7. 40 into 73 is 1. Remainder
8. Remainder 8.
40. Okay, 40 into 47 goes once.
7, sorry.
And then 40, and then we have 7, so we're 7, then we say 40 into 73. You're gonna have 73, so 40 into 73 is 1. So what's your remainder? When you divide 40 into 73. 40 from 73 gives you what? What's left over?
33.
33 over 40. Okay. So that would be your result there. Okay, now look at what they say for division. There's some similarity with multiplication and division, but there's something you need to do when it's time to divide fractions. What is that? First step. Step 1 right here.
Turn upside down the divisor, invert.
Okay, so the divisor, and which one is the divisor?
The one that we Or
the divisors are at the bottom. That's the denominator.
No, it's two. If we divide in two fractions, one of the fractions is your divisor. The first one or the second one?
The second one.
That's the one you're dividing by. That's the second one. So that's the one you're going to invert. Okay? So once you invert it, then you can go ahead and treat it just like a multiplication. So if you look at this one here, it's 1/9 divided by 5/6. So when you divide that, you're going to write it over as 1/9 times 6/5. Now, can you do any canceling there?
Hold on, I have to write it different.
Yeah, you can.
Yeah.
So what can you cancel?
And
3 can go into 9 and 6.
Okay, that's 2 and that's 3. Okay.
3. And 1 and the 5. I mean, I don't know.
1 and the 5 going to give you the same 1 and 5.
Oh, yeah, that's it. That's it. My bad.
So your answer then is
2/15.
2/15.
Right. Okay. So first step is to invert the second fraction and then treat it as a multiplication. Okay. Now, if you had a mix number, then the same step we would do with the when you multiply. And first, you need to change the mixed number to improper fraction. Then you invert the second one and treat it as a multiplication after that. Same step as you do for multiplication. Okay. All right, I'm gonna ask you to do the first two, number 1. Let's do 1A and 1B. 1A, 1B. A couple minutes and then. Okay, so 1A, what did we get?
3/8.
3/8.
That's what I was gonna say. I don't know if it's right.
Okay, so you cancel out the 6. And 3 ones 3 and 8 ones 8. Okay, what about the second one? How do you do that one?
You have to change the whole number into a fraction. So that's 42/1. And then you can cancel the 42 and the 7. And 7 goes into 42. 6 times. 6 times 7 is 42.
Right. So answer is
6 times 1 is 6. 6 times 1 is 6.
okay. So that's 6/1, which is just 6. Okay. Let's do number 3, A and B. This time you're dividing. Okay, so 3A, do we make of that one? 1/8 divided by 4/5. That's going to be equal to
1/8 times 5/4.
And our final answer would be
8/20.
8/20, yeah. No, not 8/20. What we said? You got 8/20.
I cancel out.
What you cancel?
My bad. I divided, my bad.
Yeah.
That's
5/32.
32. All right. Correct. Okay, the next one is 61/6 divided by 6/7. So following the same steps, it'll be 61/6 times what?
7/6.
Okay. And you don't have any canceling here. So you can just have to work it out. So 7 times 61 is
427.
over 6 sixes are 36. All right. So you said 36 and 42 is 1, 36, 36 and 6 and 6, 42, 67. So that's 1 again. Remainder.
So 11, 86, remaining 11.86.
Oh, no, we want it in decimal form. You divide it fully. We're trying to find out now. It's going to be something over 36. All right. 11 and 31 over. So once you know that 11 goes, 36 goes into 427, 11, you're going to say, okay, what is 11 times 36? 11 times 36 gives you what?
396.
396. But the number we had was 427. So we need to find out what's the remainder out of that 427. So you're going to say 427 minus 396 is?
31.
31. So that's your remainder. So it would be 11 and 31 over 36 as a fraction. Okay, so I could see you're gonna need some practice on this.
Yeah. Me especially. I don't know what you're.
Yeah. So even though you're free to use a calculator, when you have to do the fractions, you're gonna have to be able to know how to
convert it. I realize that.
Okay. All right. All right. So I'll send the PowerPoint with the homework questions, but your homework for this chapter would be on page 60 to 61, questions 1 to 17. Okay.
The PowerPoint should have the questions because when I called the office, they still they told me they didn't have the book.
They didn't have the book. Yeah. Well,
exactly. Yeah.
She told me she had books. I have to call her.
Okay. Well, I didn't speak of the same personally because she's on vacation.
Oh.
So. Okay. I don't know. That was just formality to say.
Okay. So you don't have the book yet then?
No, I don't have the book yet because I went to get it this week. But when I called, I think like yesterday or day before, she's like, the senior's on vacation. And when they asked me at the box, she said, no, they have any textbooks. So, yeah.
Okay. Well, when I spoke to her last, she told me she had some. But what I'll do then, I'll probably just take a snap scan of it and send it then for now until I hear back from her. Okay. Miss Thompson, you have the book?
I do.
Okay. All right. So I'll just do it for this next class. For this class, I mean. All right. Could you repeat that?
Are you going to email the PowerPoint presentation again?
Yes, I'll do that once we finish.
Yeah, those are very helpful.
Okay, that's good. All right. So now the next part to the lesson is chapter 3 on decimals. And with decimals, there are some similarities between decimals and fractions. Decimals and fractions basically are ways of doing the same thing. So I think at the beginning you said that you use the fraction to represent a portion. In the same way, we use decimals to represent a portion. And many fractions can be represented as decimals and vice versa. So in this example that you have, or the screen that you have, they're showing you, for example, you could consider a bag of M&Ms as one whole. So the bag or the whatever you call that is a pack. The pack is a whole, but the pack could be divided up into parts depending on colors. So in this particular pack of M&Ms, they have 55 individual M&Ms in the pack, and they have represented the different colors as a fraction of the whole. So yellow is 18 out of 55, red is 10 out of 55, and so on. And of course, the total ends up being 55 out of 55, which is one whole. And to the right of that, they represent it in decimal form. Okay, so 8 over 55 is the same as 0.33, 10 over 55 the same as 0.18. Now, how did they get those decimal equivalents to the fraction?
You have to, oh boy.
I guess divide.
What you divide?
The
Yes, it is the
numerator and the
divide, but what are you dividing?
The amount
numerator.
of yellow by the whole bag.
Okay, so you're dividing the numerator by
Yeah,
the
by the
denominator.
denominator.
Okay, and so that's how they converted the fraction to a decimal. All right, so there are similarities, but the representation is different. So with the decimals, we have a system based on place value, and the place value is depending on where the digit is in relation to the decimal point. So we are in the numbers that we use every day, ones, tens, hundreds, thousands. Those are the whole numbers. And of course, we could go on and on further to the right. Okay. And so the next place after thousands would be what? If you went further, sorry, to the right, to the left. If we went further to the left, what's the next? What would be the next place?
10,000.
10,000.
Then 100,000, then millions, and so on. And so the decimal point is your dividing line or dividing pointer. So your point. And then everything to the right of the decimal point now is representing fractions. And these fractions have powers of 10 as their denominator. And when I say powers of 10, the first power of 10, that's 10 to the first power is 10. 10 to the second power is 100. 10 to the third power, 1,000. 10 to the fourth power is 10,000. 10 to the fifth power is 100,000. You notice something between the power and the amount of zeros?
Each one added zero.
So the 10, the first power, 1 0, second power, 2 0, third power, 3 zeros, fourth power, 4, and so on. All right, so the power of 10 tells you basically how many zeros you have after the 1. So all of these numbers to the right of the decimal point are fractions. So when you pronounce them, remember they end in th, 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 th. All right, so the first place is the 10th place, 100th, 1,000th, 10,000, 100,000, and so on. What you do in the next place would be after 100,000.
Million. A millionth.
Right, millionth. Okay, so that's your place value chart, and the place value chart could go to the left or to the right as far as we wish. Okay, but we're just looking at this range. Okay, so this concept here of rounding decimals is what we have next. Of course, I think all of you, well, both of you should be familiar with rounding decimals. These days you have to do it, especially now that they eliminate the 1 cent. So you should understand the concept that once you have to round, the number that comes after the point you have to round off, if it's 5 or more, you round up. If it's less than 5, then you don't change. Okay, so let's look at some examples here. So the first one says round to the nearest dollar. So what would you round this to if they ask you to round to the nearest dollar? The first one.
$166.
Okay, 166. Okay. The next one says round to the nearest cent.
Cent. 1,196 and 90 cents.
Nearest cent.
For 89 cents.
Okay, 89 cents, right? Because this number right here, that's the cent place, and the number after it is a 5, so you're going to round up. If the number after it was less than 5, then you leave it as 88. But since it's a 5, once it's 5 or more, you round up. Okay, the next one says round to the nearest hundredth.
That would be $38 and 55 cents.
5? Why you say 5? 100. You have the 5 is in what place?
10 ones, the tens.
Tenth. Okay, the 6 is in the
100.
So you want to go to the nearest 100, so you're going to stop right there. So what comes after the 6? What comes
0?
after the 6? I don't see a 0 there.
I don't know, I'm guessing.
No,
What
but
does?
I want you to look and tell me what comes after the 6. You have
A
3.
3.
Right. So because the 3 is less than 5, you're not going to round up the 6. You're going to leave it as 38.56.
6.
Yeah, because that's the nearest hundredth.
Okay, yeah, that makes sense. I don't know why I thought round down.
Yeah. Now, when you're doing the penny thing, I think you round down, but with regular numbers, no, you do not round it down. We're either leaving it as is, or we round it up by 1.
Okay, yeah.
Okay. Now, the next one says round to the nearest thousandth.
$1,432 9
2.9.
8.
Okay, so the 8 is in the thousandth place, and the number that comes after it is a 1, so you wouldn't round that up. You leave it as 998. You just drop the 1. Okay, so that's basic rounding. Okay, so now, in the same way we do conversions in fractions, we also can convert the fractional form of decimals into a decimal. All right, so they give you some examples here. So if you were to convert decimal fractions to decimal, and by decimal fractions, we mean fractions with the denominator is a power of 10. So in those fractions you have there, 3 over 10, 3 over 100, 3 over 1,000, 3 over 10,000, all of them have their denominator as a power of 10. And so if you want to convert them into decimal, basically what it's saying to you is you count the number of zeros in the denominator. So here we have 1 0 in the denominator. So you're going to put the 3, 1 place after the point. Here we have 2 numbers in the decimal, in the denominator, 2 zeros. So you're going to put the 3, 2 places after the point. So in this third one, we have 1,000, which is 3 zeros in 1,000. So you're going to put the 3 places after the decimal point, and the pattern continues. So depending on what your denominator is in terms of how many zeros, that will indicate to you where the point should go in relation to the digit on top. Okay, so that's converting decimal fractions into decimal. You could do that by inspection. Of course, you could use your calculator and divide. 3 divided by 10, 3 divided by 100, 3 divided by 1,000, 3 divided by 10,000, and you should get the same thing. But this method is just showing you so you could readily do it. Some things you don't really need a calculator for. Once you see a certain pattern, then you should have some idea how to represent it in decimal form. The homework that you did last class where there are some of those percentages that were written in fraction form. Now, depending on the calculator you have, you might not be able to enter in the calculator as in fraction form, but if you're able to convert it to a decimal, then the calculator could do the calculation for you. Okay, so here we're looking at how to convert fractions to decimals. And we can divide using the calculator, or we could do our long division. And so they show you how the long division is done in each of those three examples. Okay, but I won't actually be testing you on that, but you should know that if you want to convert, you simply divide the numerator by the denominator. So if your calculator conk out for some reason in the test and you can't get a calculator, then you know that you want to convert, you divide the numerator by the denominator. Now in the questions at the bottom, they ask you to convert the following fractions to decimals, round to the nearest hundredth. Now, some of those fractions will continue on and on and on. So for example, if you look at 1/6, divide 1 by 6, then what you get?
0.16.
That's what you get?
1 divided by 6?
Yeah. Tell me what you get on your calculator.
0.1666666667.
No, it continues. So because sometimes we don't need all that those answers or those digits, we could round it off according to what you were asked to do. So in this case, they say to the nearest hundredth. So if you get 0.1666 on and on, you need to the nearest hundredth. So the hundredth place would be the second place after the point. So what would that be to the nearest hundredth?
0.16.
The number that comes after that
17, my bad. 17.
Okay, so it would be 0.17. Okay. And likewise, if you divide 3/8, what do you get?
0.375.
Okay, 0.375. But if they want the answer to the nearest hundredth, what would you give us your answer?
0.38.
0.38. Okay. Now, in the case of the third one is 12 1/8. We want to change that to a decimal. What are we going to do? (12 1/8), changing that to a decimal.
You can change it to a proper fraction, eh?
So you just have to divide the 1 by the 8.
Okay, you could divide the 1 by the 8, yeah. And what do you get when you divide the 1 by the 8?
0.125.
Okay, so that's 12.125. But now they want it to the nearest hundredth. So that would be
12.13.
okay. Now, Miss Thompson, you had said you could have converted.
Sorry?
Did you say something about converting for that one?
No, not at all.
Oh, you didn't say that. Okay, but you could have converted though. You could have said 8/12 plus 1/8 and then divide. But that would be extra work because you end up still getting 12.125. So if you have a mixed number, once you want to convert to a decimal, you could just do the fraction part and then attach the whole number to the answer you get. Okay?
Right. Okay.
And then you go from there. Okay, so these are some decimals now that we want to convert to fractions. So we're going to reverse. So the first one is 0.3. Now you know that 0.3 would be how many places after the decimal point?
1.
1. So therefore, if you're changing that to a fraction, that would be 3/10.
Over 10.
3/10. Okay, only one place, so that's. Now look at the next one, 0.24. How would you change that to a decimal fraction?
Over 100.
24/100, because you got 2 places there. 24 over 100. Look at this one, 0.24 and a half. How are we gonna handle that half? Could you write that half as a decimal?
That's 0.5.
Okay, so that's really 0.245.
Is it?
Mm-hmm. Yeah, 0.24 and a half is like 0.245 because that half is like 0.5, but we can have double points in a decimal, so we already have the point here in front of the 2.
So just put it behind it.
So it's going to be 0.245. Now, when we change that to a fraction, what would we have? 245
over
1,000.
Over 1,000.
So you just do away with the decimal in front of 5.
We're doing away with the half into a decimal. But we already have a decimal point at the beginning, so we don't need to put another decimal point in there. Okay, that's half of 1,000, which is, well, that's 1,000, so that would be 5,000, along with the 24, the 2 tenths, and the 4 hundredths. So that'll give you 245 thousandths.
So question, would we get something like 0.24 and 3/16 or 3/24?
That would be possible, but I can be honest with you, in all the time that I've been teaching math, which is probably older than you, I have never seen I have never seen a book with these type of decimal fraction mixed with fraction. This is the only book I've seen it in.
Okay.
So it's very unlikely that you're going to see this anywhere else. But since it's here, I just want you to understand how to represent it as a straight decimal. Okay?
Okay.
So it's unlikely that you're going to see that anywhere else. But looking at this next one, since you asked about the 3/16, look at this one, this next one. Before you do it into a fraction form, let's convert it to just a decimal. It could be 0.07, and the quarter would be
0.25.
25. So that's 0.0725. And then, of course, then that would be 725 over
10,000.
Okay, 10,000. Because you have 4 places after the point. So you're going to have 4 zeros there. All right, and this last one, 17 and 0.45.
$17 45 over 100.
Okay, 17 and 45 over 100. Okay. Yep. You're good to go there. Okay, so that's it, converting. All right, I guess. Okay, so let's look at these here. I have 2 of you, so I can ask you to do, it's 10 questions. So I can start with Ms. Thompson for the first 5 and Mr. Butler for the next 5. Okay, so let's look at those. Okay, so Ms. Thompson.
Hey.
The first one says, write the following as a decimal number, 309 thousandths.
309 as a decimal.
309 thousandths as a decimal, yeah.
So that would be see.
What does the thousandth mean?
To the fourth place.
Fourth?
Third, my bad. Thousandth, third.
So how are we going to write that then? As you want to write it as a fraction first then? Let's write it as a fraction first then.
Okay.
So that would be
what? So it would be 3,000.
No.
309. 309?
Okay, 309. Over.
1,000.
Okay, so now if you change that to a decimal, what would it be?
That would be 0.309.
Okay, very good. That's it. All right. Number 2 asks you to name the position of the identified digit. So what position is that 3 in number 2?
It is in the 100th place.
Okay, that's the 100th. Thank you. Number 3 asks you to say what position is that 2 in?
10,000.
10,000th place. Okay. Number 4, they're asking you to round that number twice. First, you round it to the nearest 10th, then you round it to the nearest 100th. Okay, so 0.84361 to the nearest 10th.
So that would be 0.8.
Okay, to the nearest 1,000.
That would be 0.844. 0.844.
Okay, 0.844. Okay, the next one, they want you to round it to the nearest 10 to the nearest 100.
0.9.
0.9, yes.
And 0.879.
Okay, thank you. All right, Mr. Butler. Number 6, they want you to convert to decimals. So 8 over 10,000.
Number 6 would be 0.00008.
Okay, let's see now. 1, 2, 3, 4, 5. You got 5 places, but you only have 4 zeros on the denominator.
Oops. You need another 0 then.
You need another 0?
Take away 0.
Wait, hold on. Oh, 10,000?
Yeah.
My bad. 10, 100,000, 10,000. My bad. So it's 0.0008.
Okay. All right. So you have 1, 2, 3, 4 places. Okay.
All right.
Let's look at the next one.
So let's see. 1, 2, 3, 4. So that's 1.00016.
Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 0.00016. Yeah. All right. Now, the other one now says convert the following to decimal fractions. Do not reduce. All right. So when they say decimal fractions, that means the denominator is going to be a power of 10. So 0.938 would be 938 over
1,000.
1,000. Okay. 17.95 would be 17 and what?
95 over 100.
Over 100. Okay. And then 0.03 and quarter.
That's going to be 325 over 1,000. 325 over 1,000.
Okay, so 0.0325.
Oh, so that's over 10,000.
325 over 10,000. Okay. All right. Okay. Yeah. Okay. All right. Now the addition and subtraction of decimals. I think you have enough information there on that screen to tell me what is the procedure for adding and subtracting decimals if you're doing it manually. Of course, if you're doing it in a calculator, you don't need any, you just enter it. But if you have to do it manually, what is the procedure? What do you notice?
All the decimals must line up.
All the decimal points must line up. Okay. And to aid in making sure the decimal points and the numbers are lined up according to their place, what do you notice them doing?
They added zeros.
Added zeros.
Okay. So sometimes it's useful to put in those zeros to assist us in making sure that we have everything lined up according to its place. So you're going to make sure the decimal points line up, all the tenths line up, all the hundredths, the thousands, the 100,000s, the ones, the tens, the hundreds, the thousands. So you don't have the different decimal places falling in the wrong section under the wrong type. So they should all be landed according to their place value. And the same thing applies for subtraction, okay? So you make sure they land up according to their place, and then you just go ahead and do your regular addition or subtraction to get your answers. Okay, multiplying doesn't require that lining up as such, but it requires you noting where to put the decimal point when you finish your multiplication. How do you determine where to put the decimal point when you multiply? You just multiply as you would not multiply regular whole numbers, but at the end, how do you decide where to put the decimal point in your answer?
It looked like they're counting the numbers behind the decimal point.
Okay.
And so you would add all the numbers and then you would insert the decimal point in your answer based on that.
Okay, right. So if you're multiplying two numbers, you check how many places the two numbers, the decimal, come after the decimal point for each of the numbers. So in the case of the first example, 8.52, you have two numbers after the decimal point, and then 6.7, you have one number after the decimal point. So altogether in your answer, you should have 2 plus 1, 3 places after the decimal point. And you will see them showing you in this case that the point falls after the 7, and then there are 3 places after the decimal point. Now, in the next example, you have 2.36 and 0.016. So the first number of 2 numbers after the point, the second number of 3 numbers after the point. So altogether, there are 5 numbers after the point for your answer. But in some cases, you will see where you have to add a 0 to ensure that you get 5 numbers after the point. Okay? So in some cases, you'll have to do that. Of course, with the calculator, you don't need to follow that, but in case your calculator doesn't work or you have to do it manually, then you know how to determine how to get the point for your result. Okay, now with division, they're saying to you that you have to make your divisor a whole number. And why is it that we're making the divisor a whole number? So you see that example, they give you 2.5 into 32.8. Why are we making the divisor into a whole number? Any suggestions? Do you know?
Divisor.
The divisor is 2.5.
We want to, yeah, we want to, I guess, I don't know. You know.
Mm-hmm.
Because you want to have it consistent on both sides. I don't know.
Which one is easier to divide by, 2.5 or 25?
25.
25.
Okay. The reason basically why we try to make the divisor into a whole number is because it's easier to use a whole number to divide. When you try to divide by a fraction, how many times does 2.5 go into 32? It's not so easy to figure out. But if you change the divisor into a whole number like 25, but now you have to be mindful that if you move the point to change that into a whole number, you have to do the same thing with the number you're dividing. So you'll see that it was 2.5, they moved the point to make it 25. So you have to do the same thing. It was 32.8, so they moved the point one place to make the number 328. So now instead of doing 2.5 into 32.8, we are doing 25 into 328. Now it's easy. Most people could see right away that 25 goes into 32 once. Okay. And once you know that's once, then you multiply one time, so you get 25. 25 from 32 is 7. You bring it 8 down, you continue your division. But when you're trying to divide 2.5 into 32.8, it's not as clear to work that out mentally. Okay? So the reason we are doing this is to make it easy for us to do the mental calculations when we are dividing. But you must make sure that as you move the point for your divisor, whichever number of places you move it in the divisor, you have to make sure to do the same thing with the number you're dividing to get to keep the value the same. Okay? So that's for dividing decimals. All right. So we kind of round off now with some shortcuts, which you should be familiar with. When you're multiplying by powers of 10, so in the first case, you're multiplying by 10. What happened when you multiply by 10? You had 6.89, you get 68.9. What happened there? How did they get, what's the shortcut for getting that answer?
You move the decimal point.
We're going to the left.
To the left? You sure about that? We're multiplying now. If you move the point to the left, you'd have gotten a smaller number.
Oh, sorry, to the right.
Yeah, so because it's 10,
Sorry,
you're going to move the point one place to the right. When you multiply by 100, what happened to the point now? How many places we moved it?
So it's gone. It's a whole number.
It's two places to the right. And when you multiply by 1,000, how many places you move the point?
3.
3. So the shortcut, I mean, you could do it on your calculator, but you know, certain things you could just, for mental calculation, you could see right away. Anytime you multiply by 10, it's the quickest thing to do. It just move the point one place to the right, 100, 2 places to the right, 1,000, 3 places to the right, 10,000, 4 places to the right, and so on. So that's a pattern we could use for quick multiplications of those types of numbers. And of course, if you are dividing, what happens in the division? Do we move to the right as well?
No.
We move to the left. So we follow the same pattern. So instead of moving to the right, when you're dividing, you move to the left. So if for 10, you'd move 1 place to the left, 100, 2 places to the left, 1,000, you'd move 3 places to the left. So the example is given to you for each of those, and quick ways to divide by powers of 10. Okay. Okay. Now, before we go, let me choose a couple of these for you to look at. Okay, I want to do number 1. For number 1, I don't want you to add it. I just want you to set it up. Okay. For number 2, I just want you to tell me how many places you're going to be in your answer. I just wanted to set up number 4. So this is the setup. Decimal places in answer. This one you're going to set up. Okay, you could do these ones, number 5, 6, and 7, because you're using the shortcut method. Okay, so we're just doing 1, 3, 4, 5, 6, 7. I'm gonna leave out number 2 for now. Okay, I'll give you a couple minutes to work those, and then finish up today's class. All right, so let's look at the first question. All right, so how are you going to set up that first one? Let me hear what you have to say with that one.
16.10,000.
16 point, what?
1, 2, 3, 4 zeros.
4 zeros.
Okay. Next
And
one is
0.831. And 9.85. And 17.8321.
Okay, so if you wanted, you could have put 2 zeros here. You could have put 1 0 here. And then you go ahead on the line and you add. Okay. All right, so you make sure to line up all the similar places together, and the decimal points must be in line. Okay, the next one says multiply and round down to the nearest 10. I just want you to tell me how many places should be in the answer for that multiplication when you're finished.
3 places.
3 places. So when you finish multiplying, you have 3 because you have 2 places for the first number and 1 place for the second. Okay, the next one, number 4, it says divide and round to the nearest 100th. So if you were setting this up, which number are you going to make into a whole number?
4.94.
And how are we going to make that into a whole number?
Moving the decimal place to the right, 2 places.
Places. So if you move the decimal places 2 places to the right, what's going to happen to the other number?
Then you have to put the decimal place and add the zeros.
Okay, so tell me what you'll get then.
494. Well, 3842.00.
0.00. You know, 3824.00 is the same as 3824.
Yeah, that's true. You're right.
Mm-hmm.
Divided by 494.
Yeah, so what you gonna do? 3824. What are you gonna do with that 3824? Because you move the decimal point 2 places to the right for the 4.94. So how are you gonna adjust the 3824?
That have to go to the.
So, but it's
to go to the left.
No, the same place you. Yeah, but it's the same. If you move the decimal point 2 places to the right for the 4.94, you have to move it 2 places to the right for the other one also.
right.
So both of them have to move to the right 2 places. So when you move that 3824 2 places to the right, what will you get?
So it wouldn't be. Sorry, go ahead.
It'll be a whole number now.
Yeah, it was a whole number before, but it's going to be a bigger whole number.
Yeah. So
what is
it'll be
what is
38,382,400.
Okay, yeah, that's what I have written there. But I heard Miss Thompson say 3824.00. So what I was saying to you, you don't need to put that 0.00. The point was where the 4 is, and you're going to move 2 places to the right. But since there were no digits there, you're going to just add 2 zeros.
Okay.
So it becomes 3824.00 divided by 494.
So if there were other numbers behind 3824, let's say 69, then we would put the 0.69, or no, you still wouldn't need it.
All right, so you're saying, let's say you had 3824.69 to divide by 4.94. That's what you're asking?
No, I'm saying if we had 382469.
382469
divide
by
4.94, right.
Mm-hmm. So if you have to move the thing 2 places to the right for that one, you have to do the same thing, 1, 2. So you're going to become 38246900 divided by 494.
Okay.
So remember, the decimal point will be after the rightmost digit. So the rightmost digit there is the 4. Since you didn't see any decimal point, that means the decimal point is after the 4. So if you have to move 2 places to the right, that means whatever number place, you're going to add zeros to hold the place.
So if they had given us, say, 38.2469.
Okay, 38.2469 to divide by 4.94.
Right.
Then you move 2 places to the right for both of them. 1, 2. So you're going to have 3824.69 divided by 494.
Okay.
Mm-hmm.
Thank you.
All right. All right, the next one, number 5, they want you to multiply 17.48 times 100. Shortcut would be to, what would you get as your answer?
We are going to move them to the right 2 places. So
right.
1,748.
Okay, 1748, right. Okay, the next one, number 6, they want you to divide 8,432 by 1,000. So dividing now means you're going to move to the left. And in this case, you're going to move 3 places. So what would be your answer in that?
0.008432.
No, you remember the point. The point is after the 2.
Right,
The
so
point
it'd
is
be 8.43.
8.432.
Yes, 8.432.
Yeah. So the point is after the 2. So if you're going to move it 3 places to the left, then you're going to go from the 2, 1, 2, 3. So it becomes 8.43.
So point, all the time I thought that was the comma. Wow.
Oh, that's why you say that. Okay, no, that is a comma. That's not the point. So
okay.
The point is after the 2. If there's no point, it's after the rightmost digit, right?
Okay.
So that's it. Okay, and look at the last one I asked you to look at, 9,643 divided by 10,000.
So we just assume a pointer to the end?
It will have to be at the end by the 3. So you're going to move it how many places to the left now?
4.
4 places, okay.
That'll be
0.9. Yeah.
0.9643. Yeah, okay.
Okay.
All right, so that basically brings us to the end of today's lesson. Your homework will be page 86, 85 to 86, questions 1 to 23. So I will send you the slides right after the class. So basically today we had, let me write your names down on my little sheet here. Today is the 7th of October. So this was Denise Thompson and you, Ms. Thompson, you got a course outline, right?
I did.
Okay, all right. So we meet on Saturday again, and on Saturday we're gonna have a class, and then maybe the last half hour of the class we'll be doing a quiz. And what I'll do is to email the quiz to you, and then you're gonna write your answers on, I guess, loose leaf. Take a picture of it and send it to me. I might change it to a form, but I'm not sure yet. But that's what I'm planning to do now. So just prepare yourself for that, and we go from there. Okay. Next week we will not meet on a Wednesday or Thursday next week. So I try to skip 1 week. So next week we meet Saturday. So we're meeting this Saturday, which is the this Saturday is October 9th. Yeah. And then we meet next Saturday, the 16th. And so it's the week after the 16th, we meet Wednesday, Thursday, depending on when you are free. Okay. So next week. Yeah. Okay. All right. So I'll send you, and you said, Mr. Butler, you still have the book. So I will give you another opportunity to get those questions. I'll have to scan them and send them to you. And then we meet if all goes well on Saturday. Okay. All right. See you all then. Okay, then.
Thank you. Have a good night.
Okay,
all right, good night.
Okay, then. Good night. Yes. Oh, I was still on. Okay, and